Welcome to MRL. In this learning session, we'll learn as to what happens when a line cuts a circle, what is a secant, what is a tangent, and what are the different types of tangents. So let us begin. Now we know what is a line and what is a circle. But what happens if a line cuts a circle? If a line cuts a circle in two distinct points, if you see here, we have a circle with center O, and Mn is a line which cuts a circle in two distinct points A and B. So when a line cuts a circle in two distinct points A and B, then that line is called as a secant. Therefore, we define a secant as a line which cuts a circle in two distinct points. So therefore, Mn, although a line, is now a secant because it cuts a circle in two distinct points A and B. Infinite secants can be drawn to a circle. Now what happens if a line cuts a circle in only one point? Now we have a circle with center O. Mn is a line which cuts a circle in one point, that is point P. Now this Mn, although a line, is now a tangent. Therefore, a line which cuts a circle in only one point or exactly one point is called a tangent. Therefore, Mn is a tangent to the circle with center O. And P is the point of contact. P is known as the point of contact. Remember that. Also, we have to remember that infinite number of tangents can be drawn to a circle, that is P is the point of contact, and also infinite number of tangents can be drawn to a circle. And the point of contact is the point where the tangent cuts the circle in only one point. Now let us understand as to what is the limiting position of a secant. Now I have a secant here, Mn, which cuts a circle in two distinct points A and B. If I move the secant to itself, parallel to itself, then we find that the two distinct points A and B come closer to each other and they coincide at point P. Both the points A and B which were distinct now have been converted into a single point, common point known as point P. And the point P is now the point of contact. Therefore, Mn, which was a secant, is no more a secant, it is a tangent. And therefore, remember, the limiting position of a secant is a tangent. Also, we can explain it in another way. Now, if you take a secant Mn which cuts a circle in two distinct points A and B, fix the point B, unlock the point A, and allow the secant to rotate. When you rotate the secant, you will find that the point A slowly comes closer and closer to point B, and both the points meet at a point P, and that point B becomes the point of contact, and that makes the secant a tangent. Therefore, Mn is now a tangent. Mn, which was a secant, is now a tangent, and the P is the point of contact. So therefore, the limiting position of a secant is a tangent. Remember that. Tangents parallel to a secant. Mn is a secant and which cuts the circle in two distinct points. If I draw a tangent parallel to Mn, then AB is one tangent which can be drawn parallel to Mn, and also another tangent CD can be drawn parallel to Mn. Therefore, two tangents exist which are parallel to Mn. So therefore, remember, for a given secant, only two tangents are parallel, and that is the only possibility, and therefore there are two tangents parallel to a given secant. Remember that. Now there are different types of tangents: the tangent to a circle at a point on it, tangents to a circle from exterior point, and common tangents. Even in common tangents we have got different types of tangents called as direct common tangent and transverse common tangent. Let us learn these one by one. Now the first type of tangent is tangent to a circle at a point on it. Now we have a circle with center O. P is a point on the circle, and APB is a tangent which passes through point P, and P is the point of contact. Please remember that. So P is a point on the circle, and now how many tangents can be drawn to a circle with through P? Only one tangent. Therefore, a tangent to a circle at a point on it, at point P on the circle, there is only one tangent is possible. Remember that. Now tangents to a circle from an exterior point. Now we have a circle with center O. P is an exterior point. We can draw PA, which is one tangent, PB is the second tangent. So from exterior point, only two tangents are possible. So PA and PB are two tangents which are possible to be drawn to a circle with center O. Therefore remember, tangent to a circle at a point on it, only one tangent is possible. Tangents to a circle from an exterior point, two tangents are possible. Now coming to the common tangent. A line touching two circles is called as a common tangent. So a line touching more than one circle is a common tangent. Now common tangents, as I have told you, are of different types. The first type of common tangent is known as the direct common tangent, and the second type is known as the transverse common tangent. So let us understand the difference between these two. Now this is the direct common tangent. We have two circles, one circle C1 with center O, another circle C2 with center O dash. Now MPQN is one tangent touching the circle C1 at point P and touching the circle C2 at point Q. Therefore MPQN is a direct common tangent. And why do we call it as a direct common tangent? Because the centers of the circle C1 and C2 lie on the same side of the tangent, and such a tangent is called as a direct common tangent. That means a common tangent which is common to two circles or one or more than one circle is called as a direct common tangent if the centers of the circles lie on the same side of the tangent. Now this is a transverse common tangent. If you see a circle C1 is a circle with center O, C2 is a circle with center O dash, and MPQN is a common tangent. But here the difference is the centers of the circles C1 and C2 are on either side of the tangent, and therefore this is called as a transverse common tangent. So that is the difference. If the centers lie on the same side of the tangent, it is direct common tangent. If the centers lie on either side of the tangent, then it is a transverse common tangent.